Welcome to IPLTS. In this video, we will explore the most fascinating concept in quantum mechanics, that is De Broglie hypothesis. Before the development of the quantum mechanics, the particles such as electrons or protons considered to be like solid objects. However, in 1924, Louis de Broglie introduced the revolutionary hypothesis: the matter itself can exhibit wave-like properties. According to De Broglie, every moving particle like electrons and protons is associated with a wave called matter wave or De Broglie wave. Now, what is the equation for this? You can see if the momentum of the particle P and then the De Broglie wavelength is given by lambda is equal to h by mv. What is h here? H is Planck's constant, mv is mass of the particle, v is velocity of the particle. Now, we will derive the De Broglie wavelength for the particle. Let us go here. Now, we are deriving the De Broglie wavelength. Now, according to Einstein mass energy relation, what is the, you can write down E is equal to mc square. E is equal to mc square, that is the equation number 1 I am assuming. And second one, from the Planck's quantum theory, what you can write, E is equal to hc by lambda. So, now there is the energy for the particle, Einstein mass energy relation, E is equal to mc square. From the Planck's quantum theory, E is equal to hc by lambda. Now, equating equation 1 and 2, what happens, mc square is equal to hc by lambda. Now, c cancels. Now, what happens, lambda is equal to h by mc. Lambda is equal to h by mc. Now, here every particle cannot move with the velocity of the light. So, then what De Broglie did? The real particle do not travel with the speed of light. Then De Broglie, what he submitted, that instead of velocity of the light, then he submitted the velocity of the particle v. In the final equation, what happens, lambda is equal to h by mv. So, now this is the derivation of the De Broglie wavelength equation. Now, the De Broglie wavelength equation in different terms are there, right? What are the terms? In terms of energy is there, in terms of potential also is there. We will derive those equations now. Let us go to the De Broglie wavelength in terms of energy, right? Now, we know the kinetic energy of the particle. What you can write, the kinetic energy of the particle, Ke, right, of mv square. This is a basic equation, you know, right? Kinetic energy of the particle Ke is equal of mv square. Multiply by m on both sides. So, then 2m Ke is equal to m square v square. Now, what happens here? mv is equal to square root 2m Ke is a kinetic energy. Now, the De Broglie wavelength, the De Broglie wavelength is given by, De Broglie wavelength is given by lambda is equal to h by mv, right? So, what happens now, lambda is equal to h by under root 2m Ke. I am substituting this mv in this equation, then this is your final equation, that is lambda is equal to 2m Ke. This is wavelength in terms of the kinetic energy. Now, we have two equations, one for the lambda is equal to h by mv, and second lambda is equal to h by 2m Ke. And the third one, in terms of voltage, if a charged particle E accelerated through a potential difference V, the kinetic energy can be written as what is that? Kinetic energy is equal to EV. Now, kinetic energy of the particle, what you can write here? Kinetic energy is equal to half mv square. This is equation number 1 and this is equation number 2. Now, what happens from 1 and 2, then what happens? EV is equal to half mv square. Now, 2 EV is equal to mv square, again multiply by m on both sides, then what happens? 2m EV is equal to m square v square. Now, what is the de Broglie wavelength? Lambda is equal to h by mv. Now, we can here mv is equal to under root 2m EV. Now, substitute this mv in this equation. Now the final lambda will become lambda is equal to h by under root 2m EV. Now, this is your final lambda equation in terms of potential. You can write, if you do all this calculation, substitute, then you will get one more equation, 12.26 divided by V angstrom. So, this is also one more parameter. So, this is the final equation in terms of what potential and in terms of energy also we have done. Thank you.